Now, in the next slide, this just shows the position of Kepler-11. This is a sun-like star. It's in the constellation Cygnus. It's approximately 2,000 light years from Earth, so the light that Kepler is seeing from this star left the star around the time Caesar was making his conquests. Now, if we can have the video, this is a Kepler view of the system to begin. We see this target dimming like clockwork, but like a very special clock, one with 6 hands moving at 6 different rates. And we interpret this as 6 planets orbiting very near the same plane. Now looking at it face on, and these are very close in, especially the inner 5, very close to one another, the most compact system of planets ever discovered by any technique anywhere. So if I can have the next slide, we see these planets on the occasions when they transit the star. Most of the time, none are transiting. Sometimes one is transiting, occasionally 2, and one time, last summer, we observed the signature of 3 planets transiting at the same time, which is illustrated in this graphic. Now, I've said that this is a very, very flat planetary system, and it doesn't look so flat in this graphic. But that's because the planet orbits are much, much bigger than the size of the star itself. So although they're not exactly in the same plane, when they go in front of the star, they look very similar to in the same plane. And in fact, if we had a scale model of just the inner 5 closely spaced planets around this star, it would be as flat as a compact disk. Now, the 6th planet is orbiting significantly farther out. So if we had a scale model that included the 6 planets, I had to go into the attic to find this. It would be like one of these old vinyl records. So let's move on to the next slide, please. And this shows the Kepler-11 system at the same scale as the inner part of our own solar system. So the 5 inner planets, the ones that are closely spaced to one another, are all closer to the star than any planet is to our sun. This despite the fact that these planets are, well, they're not huge, they're not Jupiter size, but they're not tiny either. They range in size from about twice the radius of the Earth to a bit over 4 times the radius of the Earth. And then that 6th planet, it's a little farther out, but if it were placed in our own solar system, it would be between the orbits of the 2 innermost planets, Mercury and Venus. Well, I've been talking about this as a system, and it is an amazing system. These planets are close in. We never thought we'd see this many planets that aren't real tiny, this close to one another. And the fact that they're close to one another means that they're tugging on each other's orbits. And we use the same technique that we use to measure the masses of 2 of the planets around Kepler-9 to measure the masses of 5, these 5 inner planets in the Kepler-11 system. And if I could have my next slide. This diagram is a little more complicated, but it's really important. So what we have here on the vertical axis is the size of the planet, and on the horizontal axis, the mass. We've observed the size by the amount of dimming that each planet causes when it transits in front of its star. We measured the masses, we've weighed, in other words, the inner 5 bodies by the amount that they tug on one another's orbit, retarding or advancing the transit times of each other by 10 or 20 minutes relative to their orbital periods, which are between 10 and 47 days. Now, we estimate the planetary radii, and we're not exact. Really, we're not exact because we know the radius relative to the star very well, but we have a little uncertainty in the radius of the star. In terms of the masses of the planets, we have an estimate by the amount they tug, but these are very small variations, so there's a bit of an uncertainty. So these ellipses for the extrasolar planets, both the 5 that around Kepler-11 that are labeled, that are in blue and labeled by the letters which designate the particular planets, and the 3 around other stars, which are ellipses of a different color, have some uncertainty, cover a different range, but they still constrain both the mass and the size of these stars, and mass and size of the planets. We compare them to 4 of the planets most like them in our solar system, Venus and Earth on the small side, and Uranus and Neptune on the large side. These are an intermediate class of planets. And of these 8 that we have, that we know in this range, 5 are around the star that we call Kepler-11. They're the ones we're announcing today. And that little red one is, in the bottom, is Kepler-10 that we announced last month and Bill mentioned as a rocky planet. Now, the ones that we found in Kepler-11 that we're announcing today, they're all higher up on this graph than that rocky planet. The rocky planet is really, really, really close to its star and really hot. These planets are kind of close to their star, and they're warm, but not nearly as hot. And we find that these are bigger for the same amount of mass, which means they must be made of lighter material. They're not super Earths. They're not big rocks. The innermost 2, C and B, they might be mixtures of rock and water, or they might be mixtures of rock, water, and gas, or even just rock and gas. But we know the 3 more distant of this 5-some, called D, E, and F on this graph, are so big for their mass, this substantial fraction of their volume must be made of the 2 lightest elements, hydrogen and helium gases. So not only is Kepler-11 telling us about planetary systems of a type that we had no idea existed, but right now it's providing our best clues on the compositions of these planets as individual worlds. So if we can move on to my next slide, this is the family portrait, and we see the cousins that were found previously, and Bill showed you in his earlier slide on the top 2 row, and the new set of 6 siblings in the family, the long-lost cousins that we found today and are announcing today around Kepler-11 in the bottom row. So if we can go to the next slide, I want to wrap up. Kepler-11 is a surprisingly flat and compact system of 6 transiting planets. The 5 inner planets are especially close together, something that we didn't think would happen for worlds of this size, and really forces us to go back and look at formation models of planets. And it also means that the planets are perturbing one another significantly enough that we can weigh the planets. We find out that they're low density, they're fluffy, they're sort of like marshmallows, but they're not all gas. They got to have something a little heavier there, so maybe a marshmallow with a little hard candy at the core. Now, we really were just amazed at this gift that nature, not the magazine, but with a capital N, has given us. And with 6 transiting planets, 5 so close to their star, and getting the size and masses of these 5 fairly small worlds, there's only one word that I can think of that adequately describes the new finding we're announcing today. The Kepler-11 system of 6 transiting planets is supercalifragilisticexpialidocious. And with that, I'll hand things over to Deborah, who'll give you the outside expert's view on what we've been announcing today.
Thank you. Well, folks, this, of course, is an amazing era of discovery for astronomy, but for